This is 2020 AMC 10A Problem 21. There exists a unique, strictly increasing sequence of non-negative integers a1, a2, all the way to ak, such that 2 to the power of 289 plus 1 over 2 to the power of 17 plus 1 equals 2 to the power of a1 plus 2 to the power of a2 plus all the way to 2 to the power of ak. Now, what is k? This problem basically asks you, how much terms are there in this expression? Because it's from 1 to k, right? So how much terms are there in this expression? That's what the problem wants. So, firstly, even if you're really stuck like I am right now, just notice that 17 and 289 have a square relationship. 17 squared is just 289. So why does this relationship exist? Well, we should find out, because this is probably a really key part to the problem. Like, maybe if it took 300, this problem would be way, way, way harder than to be in the AMC 10. So, let's just say we let 2 to the power of 289, so we let 2 to the power of 17, let's just say, equals x. This means that 2 to the power of 289 is now x to the power of 17. So the expression is x to the power of 17 plus 1 over x plus 1, which doesn't really look better, because now we have an x instead of a 2, so, well, but it's kind of useful, so if you actually look at it in the right way. So what's x to the power of 17 plus 1 over x plus 1? Polynomial long division. The first term must be x to the power of 16. Why? Because when you multiply this term by this term, you produce x to the power of 17 plus x to the power of 16. Now, you don't want this term. You only want x to the power of 17 plus 1. You don't want this extra x to the power of 16 over here. So you want to subtract that. How? You just subtract x to the power of 15. Because when you multiply this by this, you get x to the power of 17 plus x to the power of 16 minus x to the power of 16 minus x to the power of 15. So the two x to the power of 16s cancel out. So this is what you get. But you don't want to minus this much. You only want a plus 1. So you want to add x to the power of 15 back. So you add x to the power of 14. Why? Because when you multiply this by this, you get x to the power of 17 minus x to the power of 16 plus x to the power of 15. And then plus x to the power of 16 minus x to the power of 15 plus x to the power of 14. So all these middle terms cancel out, and what you're left with is x to the power of 16 plus x to the power of 14, which you don't want x to the power of 14, so you minus x to the power of 13, and so on until you reach x to the power of 1. Then you don't want the x to the power of 1. So wait, this is minus, because 1 is an odd number, and all of the odd number powers have a minus in front of the terms. So minus x to the power of 1. Until you want to add, so until there is an extra, like x to the power of 1, and you don't want that. Then in this case you would add, x to the power of 0 to cancel the x to the power of 1, and then have a plus 1. So if you don't trust me, you can try a smaller example. So this is the answer to the polynomial long-term division. We have to turn this into this. However, we have the minus signs over here, which is like our main problem. There's no minus signs, problem already solved. The answer is just going to be 17, but there are minus signs here, so we have to get rid of the minus terms. But how? Well, one thing you can do is factor out, so like you can put these in brackets, right? And then like you can factor out x to the power of, so like you can factor out x minus 1 in each of the terms. For example, this is x minus 1, so x to the power of 15 times x minus 1 plus x to the power of 13 times x minus 1 plus all the way to x to the power of 1 times x minus 1 plus x to the power of 0. So you can factor out x minus 1. So you have x to the power of 15 plus x to the power of 13 plus all the way to x to the power of 1 times x minus 1 plus 1, because x to the power of 0 is just 1. Anything to the power of 0 is just 1. But this looks even more complicated than whatever we got. Because now we have like whatever we got just now. Because now we have like multiplication between really long polynomial terms. And we have a plus 1 here. So we can't really factor out anything more or set this equal to 0 and solve the equation or anything like that. So this is kind of moving towards the hard side. But we're actually doing the right thing because we want to like remove all the minus signs, right? So we removed all the minus signs except for this. So we want to get rid of the minus 1. So how? We do so by changing this back into changing x back into 2 to the power of 17. So this is just 2 to the power of 17 times 15, which is well, let's see, 17 times 15 is 225 plus 30, which is 255. Plus x to the power of 13 times 17. So 13 times 17, which is 221, plus all the way to x. Wait, so this is 2, not x. Plus all the way to 2 to the power of 1 times 17. So 2 to the power of 17. And then 2 to the power of 17 minus 1 plus 1. Now to get rid of the minus sign, we can just like rewrite 2 to the power of 17. So how? Because we know that. So we rewrite 2 to the power of 17. We know that 2 to the power of 17 is 2 to the power of 16 plus 2 to the power of 15 plus 2 to the power of 14 all the way to 2 to the power of 0 plus 1. Why? Because when you think about it logically, these are all just subsets. So these are all just subsets of a set with 17 elements. So you want subsets of 16 elements, 15 elements, 14 elements, etc. up to 0 elements. There's that much way to choose them. And then the one last case for a subset is that you have all the elements. You have all 17 elements in your subset, so you plus 1. So if you rewrite 2 to the power of 17 like that, 2 to the power of 17 minus 1 will be everything but this. So it would be 2 to the power of 16 plus 2 to the power of 15 all the way to 2 to the power of 0. And then you don't have the plus 1 because that's just cancelled out for minus 1. So when you come back over here and rewrite everything, you have 2 to the power of 255 plus 2 to the power of 221 plus all the way to 2 to the power of 17. And then plus, so this becomes 2 to the power of 16 plus 2 to the power of 15 all the way to 2 to the power of 0 plus 1. Okay, so now you just multiply this out. Well, we don't have to, because all we have to do is we want to figure out how much terms there are. We know that here there are 8 terms, because here there's 8 terms. So there are 8 terms here, and there are 17 terms here. So in total, this multiplication plus an extra term plus 2 to the power of 0, which is 1 term, gives, so 8 times 17 is 7 times 8 is 56. So 136 plus 1 term, which is 137 terms. So why do we have 8 times 17 terms then when we expand? Because so every